product rule one more time, but this time we have a rational as the exponent. Okay, so like you've seen in the previous video, I will separate those two functions. I will name them f of x, and I will name this one g of x. So I can be all nice and organized. This doesn't have the prime right there yet. Got too excited right there. Okay, so I will go ahead and use the chain rule to find the derivative of both functions before I start working it all out together. Okay, so my outer function, here's the inner function. So outer only has the 1 over 5 right there as the exponent, and the inner function is 5x squared plus 4. Easy. Now, we're going to use the power rule where 1 over 5 goes to the front, and then you take away 1 from the exponent. That makes negative 4 over 5 on the exponent. And I will also find the derivative of this guy. So 5 is the constant multiplied by the 2. So 2 times 5, 10. And you take away 1 from the exponent right there. That makes exponent 1. All right. So the derivative of f of x function is 1 over 5. Then what do I have on the inside right there? I have that. And then exponent negative 4 over 5 times 10x. Simplify that, make it pretty. So 1 times 10x is 10x. 10x over 5 is just 2x. And then I could go ahead and send this negative exponent to the denominator, but I'm not going to yet. I will do that when I put it all back together on the original question. Okay. Now off to the side, we will find the derivative of g of x. So g of x is just 4x plus 5, and I'll do the same thing. Outer function, inner function. So I like when the outer function only has the one exponent, and when I find the derivative of that, it's going to be just 1. So the inner function is just 4x plus 5. To find a derivative of a linear function, it's just the slope. So just 4. Easy. So derivative of x is just, of g of x right there is just 4. Okay, now here's the thing. We have f of x, g of x, and I will find the derivative by applying the product rule right there. So the derivative of my cute little function right there, I will follow the formula. So f of x is that right there. Times the derivative of g. The derivative of g is just 4. Plus g of x. G of x is that right there or that right there. Times the derivative of f. F prime, this whole thing right there. Okay. As you would expect, I do have to find things for me to factor out. Can I factor it out first? I'll clean it up before I factor it out. How about that? When I look at this, it's like, man, what do I do? I would deal with this negative denominator here, and then we go from there. There's nothing I can do here. I can just write the 4 in the front, make it pretty. I'll put the 2x in the front. Make this in the denominator. Just remember, when this goes in the denominator, the negative turns into a positive. I don't like to write this small. Sorry about that. It's 4/5 right there, okay? So when it goes to the denominator, that turns into a positive. Now, from here, I need to find the common denominator between these guys. I can just simply multiply this guy by this guy. Now I have the common denominator. I'll write it over here so my exponent is not just ugly like that. So 4/5. Okay, so I'll multiply that by that. And then here, because it's the same, I just leave it alone. Okay, when you multiply, you're multiplying these guys. You add the exponents. 1/5 plus 4/5 is just 1. Okay, it does not disappear. I hope you're listening. This does not disappear. When you multiply with the same base, you add the exponents. So 1/5 plus 4/5 is 5/5, simplifies down to 1. I'll go ahead and distribute this. I should have distributed that too. Okay, I can do that on the next step. So distribute. Combine what you can on the numerator. So 28x squared We're running out of room. Okay, the last step, I will go ahead and factor out 2 and rewrite the denominator as a radical. So factor out 2. And rewrite that as a radical. I hate not writing on the line, but we don't have an option here. So when you rewrite, the denominator of your exponent is the index, and the numerator is the exponent. Whoa, we did it, guys. Well, yeah.